Hey guys, what's up? Uh, it's your guy, that guy. I've actually managed to get a little bit of a screen going on behind me. It's not much, it's not the best screen in the world, but it's fine, it's okay for now. You'll see there's a piece of wall that's like stuck here next to me. I'll figure that out next time. I didn't have a lot of time to set up today, so my initial thought was that I want to take this whole area like directly behind me. Maybe attach the screen to my chair or something. I don't know. I'll build a frame or do some funny thing. But for now, I got a tiny piece of a green screen behind me. It's just a blue blanket that I put up. So, I guess the first thing we need to do, and this is just something that I had a gripe with the last time we worked on this, is that I wanted a better editor. The editor I had kept going into full screen and then just causing issues. So then there's no way to exit the editor. So I think step one is that I found myself Visual Studio Code, best editor in the world. Where did my green screen go? Oh, I'm scrolling. Okay, I also have a microphone today. So I got a better microphone today. I don't know if you can see it, but it's a Guitar Hero microphone. I got my hands on one of these like long ago when I had the Xbox 360, and I've been Guitar Heroing it up ever since. So I guess the first thing we need to do is I put Visual Studio Code up here. I went and did a code review. I failed code review on so many fronts because I do code reviews for other people. So doing code review for myself is something that is my editor busted. Just close that. Ah, there we go. So something.js. Why is this like this? Ugh. Ugh, why is it like this? I don't like this extra tab thing. How do I get rid of this? Yeah, how do I get rid of that? View. What are breadcrumbs? What happened? Oh, they got rid of it. Great. So that was a breadcrumb. Okay, let's keep this open. Step one was that I didn't like the way this thing was working. It just doesn't work for me. I think next time I'll do better lighting. Lighting is kind of garbage here. And then obviously this extra piece that should be blue, I'll make it blue. I'll get like a thing that does this behind, like directly behind me. So the first thing I wanted to do was we're not using this. I did a little bit of a code review since the last time we saw each other. That thing doesn't exist. Let's see, does that exist? Nope, that's not used. So we don't need this dot rect width and this dot rect height, right? So we just like flying into it. So rectangle is xy with height. You could just represent this with an array that contains 4 values. It doesn't need to be an entire object with whatever, doesn't matter. We're going on the principles of the code, not the we're working on the principle of, like, we're doing oop, but we're doing stupid oop. Like this is naively following oop. This could just be like a simple structure. It doesn't need to be this. In C++, I'd actually use an array. I can show you some code. Well, I'd use a structure that has more meat to it than this. So we got a draw function. We got a playing field that takes a width, the height. Are we using this numRectX for anything else? Only here. Do we need to use it for something else? I'll leave it like this for now. We might use this. We might use up the playing field and then need to whatever, right? We like to reinitialize the playing field. I don't have to pass in this value every time, although it would be beneficial to have more rectangles for each stage, but whatever. I just want to do proof of concept. So, oh, I did some reading, some very light reading about color spaces over the weekend during my downtime. It turns out that you can do things like HSL. Right, so use saturation and lightness. So I want to change this to use saturation and lightness, right? So um, U is a color wheel from this to 360. So Rex X is just whatever color this is. We don't need to min between that and 255 because the screen width is 320 and the rectangle space, HSL color space goes to 360 in hue, so in H. S, we could just do, like, heck, I don't even know what S is. I think it goes to 1.0. And then, so it's just a S. And then L is lightness. Lightness we want to keep consistent, but we'll just do whatever this is, and then we'll do HSL, and this becomes H and becomes S and becomes L. I think that's it. We'll see now what it does. It's probably gonna mangle the colors on this thing, but that's fine. Oh yeah, I marked this as remove because we can clearly see my browser doesn't support this mouse capture interface thing, so let's just dump it. There's a rectangle intersection API. Well, there might be for JavaScript. If there isn't, there's a library we can probably download. There's a library for everything in JS. But I don't know how I feel about it. I might like it, I might not like it. It depends. So we set fill style. Oh, so we draw the playing field in HSL, then we set the fill style to RGB and draw the text, and then we restore the context, and then we do pull.draw. So if I do this, let me just find this thing. If I do this, great. We've got all mostly red. That is great. So let's just look at the HSL color space. JavaScript implementation. Here's some guy talking about it. How do you color spaces in JavaScript? Like, I read a document that was like this, but it wasn't that document. It also wasn't this page. But there we go. HSL, HSL, RGB, RGBA, HSL, HSLA, blah blah blah. So we do RGB to hex. So my question is, we've got RGB, right? So you got RGB, now you got some stuff, and now you want to go to hex, and now you got hex, and then you got some stuff. I don't care about hex and RGB. I care about. There we go. Oh, so if you look at H, right? H and S and L are, yeah, U is a value from something to 360. Yeah, well, something's broken. So we do HSL, HSL. So my assumption, and this is just like a silly assumption, is that my assumption is that S and L need something special. Oh, check HSL H and then S% and then L%. Okay, so you can't just do that. So let's just Control X that. 50%, 50%. Well, saturation is always going to be 100%. Let's just say something percent, something percent. Let's see what that does. Hopefully it does something. Yes, there we go. See, much better colors. Okay, great. I'm happy with this. This looks amazing. Now you can see that all the colors are now evenly distributed across the board. A function of lightness could be the distance from the top of the board. So I goes from 0 to, like, I don't know. It couldn't be 100 rectangles. 14 by 10, 140. So we could just do I divided by let's just do this. Let's be silly. So we'll say L equals I. No, you can't do that. You can't do that. Can't do that. I'll tell you why. I divided by root width. Oh, I divided by number rect y. L equals I divided by num rect y. So I divided by num rect y. We're just gonna dump this. I divided by num rect y gives you a row, right? And there's 14 across, 10 up, so we can do times 10, and then we do 100 minus. And then this just becomes $L. Let us see if this does the thing we think it's going to do. No, it doesn't. Huh, interesting. Okay, so ideally what I would have wanted were ideally what I would have wanted would be that it becomes lighter as you go along. 100 minus I divided by num rect y times 10. So lightness is 100%. Oh, forgot the percentage symbol, that's why. So it's freaking out, it doesn't know what we're doing. If I take this breakpoint off and then continue, there we go. Do I like it? Do I not like it? I could say 100 minus that divided by 2. Let's do that. Let's just do that. There we go. Much better. So it becomes lighter and lighter as you get to the top. You could also go 50 plus that if you want to go the other way around. So if you want to go 50 plus that, oops, not plus 6 plus that, it'll go lighter and lighter as you go. So I don't want it to go all the way to white. White is a very nice mixture of all the colors, but it doesn't help us in this instance because it looks like your playing field kind of just fades. There we go. Absolutely perfect. So one thing I realized over the weekend was that even though the ball is amazingly placed, it is larger than all the rectangles. It is much larger than all the rectangles. I want that to be fixed. I want that to not be that way. I want for it to not be like that. So I want to just kind of tweak the rectangle size a little bit for the ball. Let's say 6. And then we need to go find every calculation that references the ball and tries to do a calculation with it and make sure that it's using ball dot width and not just some contrived value. Oh my word, I was actually fairly consistent with using ball dot width. Okay, so let's just see this. Much better. Much better. It also looks neater now that the ball is like virtually the size of one of these rectangles. So what we need to do now is we need to say, is the ball we need to figure out if the ball is intersecting one of the edges of one of these rectangles, and this is a solved problem in software development. Let's just get paint. You know, my start menu that nope. Yeah, there we go. I probably have Paint open, but I just say, you know, screw it, let's just open a brand new one. So this is a solved problem in software development. There's something called axis-aligned bounding boxes. So for instance, if you are trying to collision detect against a plane, what you would do is you would say, give me a second. You would say, I have this bounding box for my object, and let's just say your object is whatever the heck that is. There's a name for this shape. Star of David. Is there 6 points in it? 6. I think this is Star of David. I'm not sure. But let's say you have this shape, and this rectangle, this red rectangle, is the bounding box. The reason it's called axis-aligned bounding box is because this thing's x-axis is aligned to a theoretical Cartesian plane, so it's running parallel to an actual x-axis on the theoretical Cartesian plane. Let's just represent that in this fashion, right? And then its y-axis is aligned to a theoretical Cartesian plane y-axis, right? So these axes are aligned to a hypothetical Cartesian plane that just it kind of lives somewhere in your heart. If you really want to be pedantic about it, you could define it somewhere in your code, but it's always mathematically defined as two opposing axes, one going straight up and one two adjacent. I don't want to do 7 red lines. It's two adjacent axes, 90 degrees offset from each other, right? So that is your Cartesian plane, that is x and y axis. So x always goes across this way and y always goes up that way. So your axis aligned bounding box, no matter what you're doing with the shape inside, you just draw a bounding box around it that says, you know, here is this y axis that goes up or down, whatever. It's 90 degrees offset from the horizontal plane, and the horizontal plane represents your x axis. So now when you do collision detection, you can actually check each edge of this axis aligned bounding box. Now obviously it becomes a little bit of a hairy issue if you're doing non-rectangle collisions. For instance, if you're trying to actually pixel perfect detect that star, you'd do like a 2D raycast. Once you detect that the bounding boxes intersect, you'd start doing a raycast to figure out which surfaces are actually touching, but that's like super far along. So for now, all we want to do is we want to find, are these things touching here? So is, oh no, the up and the down arrow. So all we want to find is this plane touching this box at any point, right? And obviously, in the original Arkanoid, the detection happened at any point. So you could detect this edge against a rectangle. You could detect, I'm running out of arrows. You could detect that edge of the ball against the rectangle, and you could detect, come on, bring it in for the win, that edge of the ball against the rectangle. So I think today we'll do this. We'll figure out, are any of these edges touching, right? So I don't have an immediate idea of what to do. But let's say we first, let's not do a rect intersection API. Let's do like a. There's this thing called a ball, and there's this thing called a rect, and they are both rects, right? Okay, great. So rect dot prototype dot intersect. So since we don't have an intersection API, we'll just pass in other, which is a rect, and this thing returns true or false. It should actually return true or false, right? So the default is return false, and I'll tell you why the default is return false. So first we'll check loop through, one day I'll be able to type all rects and figure out if any intersect at all, and then the next function will return which edge intersects. So rect dot prototype dot find intersecting edge, and it also just takes other, and I'm just typing garbage here. This should be equals function, which takes other. Same thing here, equals function other, and then that function other would just return, I think, let's define it right now. 0 equals left edge, 1 equals right edge, let's just do that, 2 equals bottom, and you can see the error. So left, actually, should we start at the top? Yeah, let's start at the top. So top, right, bottom, and 3 equals left. So it's going from 12 o'clock all the way around the clock, right? So it's going in a clockwise fashion. You could start at the left as 0 is left, 1 is top, 2 is right, 3 is bottom. It's actually nice. Start at 9. It's nice and early, but not too early. Also nice and late, but not too late. Whatever, doesn't matter. I'm not designing an API. I'm just using this language to like put together something, right? It's not specifically going to teach you anything about the language. It's more going to teach you a couple of concepts. Like today we dove into color spaces, and now not to screw up your code by forgetting a % symbol, right? As I've done. Do what I say, not what I do. Do as I say, not as I do. So obviously the first issue is, you can, if you struggle with RGB and getting a proper color distribution, you can just go into HSL, gives you a nice pretty spread of colors, and Bob's your uncle or whoever. I don't have a Robert in my family, but if he were in my family, he'd probably be an uncle. So we want to find out, do any rectangles intersect? And if any intersect, which edge is intersecting? And this is while we're doing update ball. So here's the kicker though. If the ball intersects any of the edges of the screen, should we short circuit? So should we just return early? And then the same thing, yes, if the ball is greater than the inner height, that's actually a fail condition. That is you died. If your ball went down beyond the height of the screen, it means your paddle missed the ball and you died. You missed the ball. You did a what's it game of the bats? Not golf, not football, tennis. If you miss tough, your point gets deducted. Should we subtract lives? Should we start you with 3 lives? We should start with 3 lives. Whatever. So this is, you must the ball do something. This requires a state, but in this state we can say return early. And you'll see the reason why we return early now. So if the x is less than 0, we'll also just return early. And if the ball y is less than 0, it means you touch the top edge of the screen, but you haven't actually hit anything. So it bounces, and then we return early. So in this instance here, if you've hit the paddle, we also return early, right? If you've actually hit the paddle. So here's all the return cases, and now you'll see why we did return, because I want to know playing field direct. So find intersecting rect function at the rectangle. So find intersection rect would actually just return -1. I'll show you what this means now. I'm just thinking about how this would work. So for intersection idx equals playing field dot find intersecting rect. Oh, and here's my OCD just like jumping out here. IDX, and then find the intersecting edge with the IDX, right? So we could do something like playing field dot find intersecting edge with playing field dot find intersecting rect. But why? Why can't we just pass ball in here and then it internally just does find intersecting edge, right? Why wouldn't that be nice? So var intersecting edge equals find intersecting edge with the ball, and if intersecting edge greater than -1, which means it's 0 or above, then change direction based on the intersection. So here's the issue though, and this is something that I always end up thinking about when I'm busy writing code, because you can see I just write the code, I think about it a little bit, I just write the code. But the idea is, if I want to find that intersecting edge, I want to mark a rectangle as hidden. Whose responsibility is that? Is that the responsibility of the playing field? Should the playing field know that if something hits it, then it should be hidden? And in true OOP, most likely yes. You'd say if something intersects with this, the playing field would be smart enough to know that if something intersects with its rectangle, then its rectangle should be marked as not visible, and the score should be incremented, etc., etc. But this isn't OOP. This is schloop. We schloop through the things, we through the stuff, and then, no. It's a mixture. I want to do MVC, but I don't really want to do MVC because MVC would have me breaking this out into classes and formalizing the API and making contracts, because the controller needs to understand what the model is. So the controller needs to tell the model. No, the controller needs to tell the view, this is your state. So I'm not leaning towards MVC today. I'm leaning towards like broken OOP, more functional style than anything else. I don't mind functional code. Functional code is amazing. It is the bread and butter of this world. Without pure functional code, you wouldn't have things like banking software, because you need to minimize side effects if you're doing banking software. So most of that's written in a procedural and very functional fashion. I think most of NASA's stuff is also like pure functional, if I'm not mistaken. There's like a lot of important things that require functional or procedural programming style. Source 3, go away. There we go. So I would like to know at this point which edge intersected, and if the edge intersected, then I want to say score plus equal to 100 points, right? And then switch the intersecting edge, and now we can do something like case 0, it hit the the flip did it hit? We did the sum, it hit the top. So if it hits the top, it's the same as if the ball is less than 0, right? So then we do ball blah 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 something. So we do the same thing, right? So my question is, shouldn't there be little functions here called ball hit top, ball hit bottom, and then we call them? No, we'll just repeat this code for now. I'm not doing a this is how you write code thing. I'm doing a this is how I get. What? Huh? That's weird. That wasn't working for a second. I'm doing a this is how I write this thing, right? So case 0 do that. Case 1 do something. Case 2 do something, and case 3 do something, and the default is just lose your mind, because you shouldn't hit any of these defaults if you've done everything correctly, right? Okay. Case 1 was it's right. Yeah, so it's right. So it's the same as if ball.x plus ball.height is greater than inner height. So it's the same. No. Ball.x plus width is greater than inner width. It's this case, right? So this is right. So that was top. This is right. My machine's running a little bit slow. Actually, how do I want this code formatted? Do I want it like this? Here's the weird thing about this editor. I've been using this for a while, and I know it's gonna fight me on this. The moment I do some change, it's gonna just try and format that thing for me again. So case 2 is bottom. Bottom is this instance where ball y plus ball height greater than inner height. So I want this ball to bounce, right? So I want this thing to bounce and then jump out of the switch. One of the interesting things is that switch case has been fairly consistent in most of the languages I've used so far. Like it's been just incredibly nice. So what is this last case? So this is top, right, bottom, left. So this is ball x less than 0. So this would be the trajectory of the ball. And then there's only one way you can actually hit any of these cases. If your ball is traveling left, you'd hit the right edge of something. So your intersection should return the intersecting edge of the ball. Yes. I don't know. Are you guys following? Are you not following? I don't get comments on these videos. I'm assuming it's because I've got one dedicated viewer. If you're listening, it was. Oh, yeah, I'm logged out. I forgot that the last time I had to go and do like a weird shift change thing at my workplace, because I swear I hit the stop button to say I'm done working, and then I go over and do the video, and I look in this little thing, and it turns out like the flip. I'm still in here. Like, why am I still in here? Like, what's happening here, right? It's just the weirdest thing. It upset me a fair amount. What's up with my account? I have like a an amazing subscriber, right? What's that? There we go. He's actually the moderator of another channel. I just want to find that channel on my YouTube and then shout it out. Maybe just paste a link to it somewhere. In the description maybe. But anyway, so if you have issues and you find like, oh, this is a terrible coding style, which I'm sure many of you would find like, oh yeah, this is just the worst thing ever, right? That's fine, I suppose. It's not an issue. There's nothing like wrong with that. Um, oh my word, how can I not operate a YouTube? I need to go to like settings or something because I can't find the channel thing. Like it doesn't make sense. I'm sure I had a channel thing set up on my somewhere, but I can't for the life of me figure out where it is. Switch account. Ah, there we go. I need to switch accounts. So let's just find this. There's this amazing channel out there. It's called Game News Intel. It's got like everything you'd ever want, anywhere in anything. You get like OSTs and you get a bunch of stuff. Oh, Chrome doesn't want to give me the. There we go. There. Game News Intel. Look at that amazing channel. Right. Go subscribe. As you can see, I haven't subscribed. Boom, I'm subscribed. It's got everything. It's got like clips. It's got gameplay trailers. It's got OST. It's got everything. So subscribe. Do the thing. Be a reasonable person. Do the thing. Okay. So let's get back to coding. So yeah, we need to figure out which edge intersects, and if these edges intersect, then great. So I want to name this playing field dot find intersecting edge of ball. That makes so much more sense, right? Playing one day this thing will like scroll all the way to where I need it to be. So playing field dot find intersecting edge of does not take an IDX, it takes an other, which is the ball. First thing we need to figure out, do any of these things intersect? So very straightforward, right? For I equals 0, start with that. I is less than the start length I plus plus, and clearly we can see there's an error, semicolon. Great. So let's go do some geometry. As you can see, I just love my paint thing. So lovely. So let's say you have a theoretical Cartesian plane and it is centered around the 0, 0 point. I'm just going to use that thing to draw 0, 0. And you've got this x axis leading that way, and then you've got this y axis leading this way. Okay. And then you've got this rectangle somewhere in that plane, right? And you've got another rectangle. Oh my god, I want darker colors. There we go. I want that. Yeah, give me that purple, the deep purple. So say you've got these two things. I want to know if this thing's coordinate is, let me just get Notepad up here. Let me just jump through these hoops again. Nope. No, not Notepad++, just plain old amazing Notepad. I would never call Notepad boring. Shoot, what have I done? Nope, not that. There we go, Notepad. So let's say the red rectangle, so r position equals, I don't know, like 10 10, and the width is 10 and the height is 10. Let's just do something. And then the blue rectangle is, just so you know, this is x, y, width, height. Just for intersect, let's make it 100. And then that thing's position is 200, 200, and its width and height is 100 and 100, right? There's a mathematical formula you can use to determine if these things intersect. You can say and let's just see if it works either way. I want to subtract this x coordinate from that x coordinate, right? So if I want to say br.x minus rr.x equals br.x is 200, right? Minus rr.x is 100. 10. 200 minus 10 equals 190. The distance between these things is greater than the width of this RR, right? So that means that these two things can't be touching, right? So let's see if it works the other way around. So if I say rr.x minus br.x, so rr.x minus br.x equals, that is 10 minus 200 is negative 190. So you could just say the x distance equals the absolute value of uh, rect 1 dot x minus rect 2 dot x, right? And if that, I'll just call this dx, not x distance, just distance x. I know dx is usually delta x, but let's just call dist x. If dist x is greater than the width of, oh, but there's an issue. If you say rect 1 minus rect 2, then that dist x needs to be greater than the width of rect 2. So if you say this thing minus that width needs to be greater than this thing's width. So rect 2 dot width, then these things are not touching. Simple as that, right? You just gotta keep the order in mind, because obviously the widths cannot be the same. The widths would not be the same in like a real world usage. So let's do something. Let's say this thing is within that bounds. This will satisfy the condition because the distance between these two will be less than this one's width. But now let's say this is the case, right? So then this thing's x is now suddenly, what was it? This one's 200, 200. Let's make it, it's 10. Shoot, I really didn't choose a great coordinate system for this. Let's make this positioning 100, 100. And then the widths will just be like something like 50, right? That way we can move them around the screen like with impunity, without having to care that they suddenly look off. And also the calculations don't get mangled because I have to work in negative coordinate spaces. So now this thing is this thing's x position is 100 on the screen. So this is 100 here. Now you move this rectangle over here. Its x position becomes less than 100 by at least 50 pixels, right? If it was the 50 pixels, it would touch. So it needs to be less than 100 by say 50 plus 10 pixels to get a 10 pixel gap there. So its X position now suddenly becomes 40 pixels, 40 on the screen, right? So if we do the same calculation, right, we say dist X equals abs of, and here we're going to choose this blue rectangle as rect1. So rect1 dot x minus rect2 dot x equals, so this thing's x is now 40 minus this 100 pixels. So 40 minus 100 is what, minus 60 pixels, right? And is abs of that thing, right? So abs of that, or we just call it dist x, is abs of dist x less than, oh shoot, what did we call that? Rect1, no, rect2. Gotta make sure we do it properly. So this is rect1, this is rect2. Oh shoot, so this moved. Okay, so we do is it if rect1 minus that is rect1. Oh, okay, so I see the problem. For this formula to work nicely, you gotta make sure you always choose minus 60 is actually less than this and less than that. But this doesn't help because these rectangles are moved around. You always gotta make sure that rect1 is on the right? So, easy way. If other dot x is greater than this dot rect I dot x, right? Then we'll do the calculation one way. Actually, what happens if it's equal? It's definitely intersecting. It should be intersecting if it's equal. So we'll just do greater than or equal to. So if other is the ball, right? So we'll just call it other because this is the prototype of the function. We don't know anything about ball in this function. We just know there's this other rectangle we want to check. So if the other rectangle x is greater than this thing we're checking dot x, then other equals rect1, right? So you'll do other x minus this rect x. Yeah. So then var dist equals other x minus this thing x. We'll just do absolute value of that because it can be negative if something happens. Absolute value is needed. So this is JS, right? Is this math.abs? Or is it just abs? Oh, let's go check it. Oh, this is csstricks.com. It is a great resource if you want to do anything in CSS or in JavaScript or whatever. You can very easily, so just go to css-tricks.com. You can get like whatever you need in there. So I want to know JavaScript apps. I'm assuming it's math.abs. See, easy. Don't even need to go into the page. So this equals math.abs, and so if other is rect1, so let's just go back to notepad again. So we did rect1 minus rect2. So if it's greater than this thing, right? So if dist is less than this width, right? This means it's somewhere in the x axis region, right? So now we know this thing intersects, right? And if it does intersect, we need to do the same thing in the y-axis to understand is is it intersecting in the y-axis? So I want to split this out into functions. Oh my word, I really want to split this out into functions. I don't like the way this works. So whatever. I don't specifically have that much time, but this will give you a general idea. So we do the y-axis now. So uh, if x intersects and y intersects, this is gonna be such a mess. Is there an easier way to do this? I know I've seen there be an easier way to do this. So JavaScript rectangle intersection, rectangle to rectangle intersection. Yeah, I've only ever seen these things, right? So R2 left greater than R1 right, or R2 right less than R1 left, or R2 top greater than R1 bottom, or R2 bottom greater less than R2 top. I like this. I like this a lot. Okay, so let's keep this in mind. So A left less than equal B right, and A left B left less than equal A right, and A top less than equal B bottom, and A top B top less than equal A bottom. Uh, if the maximum of A left or B left is less than the minimum of A right or B right, and the maximum of A top or B top is less than the minimum of A bottom and B bottom. Yeah, I don't like any of these. What is this? These guys are saying they are point types and rect types. No ways. JavaScript rect? I don't think that. JavaScript rect. That's P5. There is a canvas. Rect JavaScript API. Let's see. No ways. These guys are saying. Oh, geometry.jsm. Ah, there's an intersect function. I don't believe this is a thing. Let's just check. Find intersecting edge of just return -1. Right. But then I want rect a no a what does this thing say? I've never ever seen this thing. Rect a equals new rect. Actually, let's just stick this not here. Let's put it in the one-time init so we don't just spam this thing with like errors. Equals new rect a dot. Yeah, this thing doesn't know about it, so I'm fairly sure that thing doesn't exist. We think it exists. Oh, what are the properties? X, Y, width, and height. So x equals 0, a dot y equals 0, a dot width equals 10, a dot height equals 10, and this isn't correct. There we go. Because if there's already a Rect API, why am I building my own Rect API? I could just smack prototypes on it, right? So Rect, let's see, does this compile? Nope, doesn't compile. Inspect. One error, console. Yeah, thought as much. There's no such thing. Okay, cool. So I'm not losing my mind. With that said, though, let's go see what these guys have done, right? Not that one. Yeah, let's see what these guys have done. What is this? Components, utils, import, geometry, GSM. What in the heck is this? Ah, there we go. They should have this on every flipping page, right? Like, my word, they sent me down a weird rabbit hole there. Okay, so let's just continue down this path. So we have a way to see if the x intersects, right? So we can see if the other, so all we want to do is r 1x equals other x greater than or equal this rex dot x, yes, then r1 is let's just call it right and left. Right equals other dot x greater, then right is other dot x, right? Var left equals just the same. This obviously has an else case. And the left is just the less than case. So if this thing is the left, then it's other dot x, else it's the rect I right. So let's evaluate this. The right hand side is if other dot x is greater than or equal to this rect x, then it's the other, it's greater than. And the left is if the other x is less than this rect x, then it's the left. Okay, great. For top equals same thing, right? So it's like literally the same thing. So the top would be if the other x is other y is less than this rex y, then the top would be other y also would be this rex y, right? And then the bottom is just the inverse of that. So bottom greater than or equal, then it's otherwise blah blah blah. Great. So we don't need this check. So we do var distance in x is math abs right minus left. So var right and var width. R width equals if other is going to be the rightmost rect, right? Then the width I want to check is this thing's width. Right? Else it's other dot width. Right. So if this is less than R width, then it's somewhere roughly close by. So then we do the same thing here. We check against something's funny here. 4. Oh, blur. One of these brackets aren't needed. So we check this quickly. So I just want to get to a close. I want to just get collision detection in here and then be done with this thing. Okay, so if the distance x is less than the something width, then it's somewhere in that region, and we say we need to do the y the y test, right? So we check if the distance y is less than the bottom minus the top. So then if dist y is less than or equal to our height, then it's intersecting. This is definitely intersecting. Let's just return 0 in this instance, right? So we'll say, okay, boom, we return 0, and actually we can just return rect I. So we'll do something here. So we'll figure out now which edge is actually intersecting, right? So yeah, our width is other x is greater than the width is that. So other bottom is other height is, so if it's the right, then it's the width. If it's the left, it's not the width. So if it's the bottom, is the same check. So var or height. If other dot y, so then it's just this rect h, else it's other h. Okay, great. So if it is intersecting, right, we need to know which edge is intersecting so that we can bounce this thing. How are we going to know which edge is intersecting? Because we need to know the intersecting edge of other. So with all this written, I have an interesting idea, right? We do the check and we say, okay, great. So something intersects, but now I want to test. Say this thing is actually touching. I want to test the top edge and the left edge and the right edge and the bottom edge to figure out which edge is intersecting. So how do you, is there a relationship you can use to determine this? Let's do that. I don't think it would ever come to that, but let's just do that. Okay, I have a couple of ideas here. Actually, this is totally the wrong thing I'm typing in any case. A rectangle has a prototype pointing rect function which just takes an x and a y, right? So it's other x and other y, and then all it does is it determines yes or no. So return true or return false. The default would obviously be false. So then this is actually a function of the playing field, right? So boom, playing field prototype draw, playing field constructor. Yeah, this is actually playing field. I don't know why what I was thinking on the day when I typed rect there, but that day was today and I can't remember. So let's just make sure that the check I'm doing is correct. So blah blah blah, ball, playing field, find intersecting edge, do all the things. Okay, great. So the intersecting edge would just be 0, 1, 2, 3. So the thought I had, and you saw me playing around with this rectangle, is the thought I had is that I would just want to test the top left edge and the top right point and the bottom left point and the bottom right point and see what it shakes out, right? So let's see what happens. So is point in a rectangle, return OX is greater than or equal to X and OX is less than or equal to X plus width, and OY is greater than or equal to Y, and OY is less than or equal to Y plus height. Well, I guess that returns true or false. So here we can return, right? Shoot. Are we gonna return? How are we gonna return top? We need to test something. Okay, well, we got a point in rect function. So my thought is I want to know. Okay, let's try this. Let me just go find. Here we go. So definitely intersecting. So I want to check the top left edge. So I want to say if, and I want to check the top left edge of the ball, right? So this is actually just find intersecting edge of ball because this is not a rectangle. It is a playing field. The playing field knows about the ball, but let's just call it other because I don't feel like replacing all these things. So I want to check the top of the ball, right? So I want to say other dot y. Well, no, I want to check the. Yeah, I want to check the. So there's only really four things that could be happening here, right? That we care about, and that is, so if this red thing, if this blue thing is the ball, we want to know, is the ball touching here, or here, or here, or here? Very straightforward. So we'll test this case here, right? Is the ball touching the bottom? So I can take the x, doesn't matter. The x can just be the midpoint of this rectangle, right? And then the y can just be the y of the ball. So then it will do, is this y going in there? So let's do that. So do the top edge first. So if this dot rect I dot intersect point in rect, point in rect, and yeah, we can do this rect I dot x plus this rect I dot width divided by 2. So you can do this x plus this rect I dot width divided by 2. It would be amazing if I could just like hit that dot. Okay. So does it intersect with other dot y? So if it does, then we return top. Boom, sorted. See, it was going somewhere. I now I get confused while I type, but it was going somewhere. So that is the top, right? So we'll do top, right, bottom, left. It's most likely the same. So let's just do top. So if this is the top, so this we can do. If the point is in rect, so we did top, we want to do right. So to do right, to do top, we did what? Let's just visualize this. So to do top, we tested this y against that middle point. So we want to test this x against this middle point, right? So the x we test is the ball x, right? So yeah, so right is just the ball x, so it's other dot x. And then the y would be this funny calculation, right? Yeah, this is here where it slips. Boom. Y plus height divided by 2. Okay, so we now understand the top and the right. The oh shoot, this is not the top. This is the bottom. Well, actually, it's the top and the left of the ball. So the top of the ball is touching the rectangle. The left of the ball is touching the rectangle. Let's just keep that very clear. There's so much room for confusion here if you're not paying attention. So yeah, the top of this blue thing is the ball. So the top of the ball is touching. The left of the ball is touching. Let's do the bottom of the ball is touching, right? So for the bottom, we'll do ball y. The x would be this red thing's x plus its width divided by 2. So let's do the bottom. So I want to test the bottom of the ball, right? So it's going to be that thing, and then the y calculation is the its own x halfway. Yes, its own x halfway. And then the y is the ball y plus the ball height. So other dot y plus other dot height. Great. And then the the right hand side would be the x would be this thing's x plus its width, right? So which one was this? Bottom of ball. So this would be other other dot x plus other dot width, and we test it against this x y plus this x height divided by 2. So it's just the midpoint of that left, so the midpoint of this thing. So this would be right of ball. Okay, great. If I haven't lost my mind somewhere along the way, this should at least give us some kind of idea of whether things are touching or not. I don't know. But if things are touching, then it should mark that rectangle as invisible. Oh, interesting. So if this dot rect I dot visible, if it's just flip this test over. If it's not visible, then just continue to the next one. And if it hit, definitely intersecting, right? Then this dot rect y dot visible equals false. It's like the first thing you do. It intersects, and then afterwards you figure out like which the heck point. So top of the ball is 0. Left of the ball is 3. Bottom of the ball 2. Right of the ball 1. Let's see if I've lost my mind. Nope, it looks like I've lost my mind. So what is the deal? How do we debug this? Sorry, just checking if my lovely wife is screaming at me. Oh, reference error. Oh, that's interesting. Why would I spell that wrong? 151. Where would I spell that wrong? That's interesting. Who even spells it incorrectly? Okay, different error somewhere. That's such a weird one. I don't even recall where I would have typed that. So let's see. Okay, great. So you got that. And you check bounce. And now what do? You say I'm willing to bet it's throwing a fit right now. Yeah, it's throwing a fit. Okay, 24x. So x, it's just like this random x that sits in the middle of nowhere. So 24. Blah blah blah. Oh yeah, this dot. So it's gotten through the intersection test, right? But now it's bulking because I forgot to tell JS which x and y and width and height, which obviously it can't possibly fathom because in this function there's only one x and y and width and height. That couldn't possibly mean this one. So let's just see. Oh, great. So bounce and do the thing and boom. Oh. Okay, great. Not exactly what I thought it was going to do, but close enough. It. Oh. And I'll tell you what's happening here. It is the precedence of the test we're doing. We're first checking left bounce or right bounce. We should be checking top bounce first. That's why it's not bouncing back. So we should be checking top and bottom bounce first. We can solve this. So let's just check if we check the top of the ball, right, against the ball dot y. So the middle of this rectangle against this balls dot y. And then we check the bottom of the ball and then the left and the right. So it should work. I just want to do like a little hack here, and I'll tell you why. +1. I'll tell you why. I'll show you why. If you don't want this weird behavior, right? You want it to like 100% definitely work. Then you want it to be able to bounce. No, it's still doing the wrong thing. Left and right work fine. Top and bottom are not exactly right. Let's just see what happens. If the top of the ball bounces... Wait, that's not right. Top is 0. So check this out. Check this weirdness. If the top of the ball bounces... It must be y. dy is 1, dy is 1, ball dy is 1. If the right of the ball bounces, then dx is -1. If the bottom of the ball bounces, actually this is -1. If the bottom of the ball bounces, 1. Let's just check that. The behavior is funny. Like we'll fiddle with this now. Let's just see. We do that. It should bounce downwards, right? No. I think what's happening is I've swapped top and bottom around. So this should, at the moment of impact, yeah, I've swapped top and bottom around. So let's just define top. 0 is top, 1 is right, 2 is bottom, 3 is left. 0 is top, and then go clockwise. So 0 is top. So we check top. Does this y intersect somewhere in the middle of this rectangle's x, right? And that is the top of the ball, and that is 0. And if the top of the ball intersects, then we set the y to 1. If the bottom of the ball intersects, we set the y to -1. Okay, that's 1 done. If the bottom of this ball intersects, right, then we return this bottom value. Bottom is definitely 2, and if it's bottom, then the y flips to -1, which means it goes upwards. Let's just check left and right and then call it a day. So if left of this ball intersects, then we return 3, and 3 is definitely left. 3 should actually be x -1, right? 3 is the left. So if it is 3, it also going -1. It's going -1. Then left the dx becomes 1, and if it is right, it becomes -1. +1. This should give us a thing that bounces, right? So you can always just place the paddle there. Boom. There you go. Okay, so what did we learn today? We learned today that you can mathematically describe a bunch of garbage. I don't think I should be checking the left and right edges, to be honest. I think I should only check the bottom and the top. I'll go watch some videos of how the original Arkanoid works, but I honestly think those guys aren't checking left and right edges. I think they are checking only top and bottom. So I'll go watch some amazing YouTube, and then I'll come back and we'll maybe edit this as a part 3 or part 4. For now, I'm super happy with how this came out. We did a simple stupid game in like couple of lines of code. We'll just do the code count. And I just want to get to the second row. I'm actually super happy. I just want to see if the left and right edge intersect is working correctly. If not, I'll just take it out. So obviously, and of course, it's now going to be like a stupidly weird bounce, right? It's going to be like the weirdest bounce in the world that just doesn't want to hit the left edge. I'm happy. We made sure that it takes precedence for top and bottom. So I don't even think we'll get... Oh, there we got a left edge bounce. Okay, I'm happy with that. I'm super happy with that. So we'll call this here. The next thing we need to add in is... How many lines of code is this even? I really want to rework that calculation. Like, really want to rework that calculation. But the next thing we need to add here is... Let me just put the comment in. In screen or something, something we can work towards. So in like 200 lines of JS, you've got Arkanoid, and this is like neatly spaced out and like stupid maths in here. So I'm happy with this. Guys, again, if you enjoy, like, comment, subscribe. If you don't enjoy, well, tough. I'm just a guy writing code here for no reason. Have fun, enjoy. See you next time. Stay safe. Cheers.